Hello, everybody. We're going to talk about section 6.1, the graphs of sine and cosine here. So here we have a table of some of the commonly used angles, reference angles. And we went over these in a lot more detail in chapter 5, in section 2, back before break. But so if you were to make a graph of this, so if you were to graph, for instance, 0 radians, that's going to have a value of 0 for the trig ratio. For pi over 6, which, let's see, pi over 6 is roughly 0.5-ish. And then that's equal to 1/2. So basically you're at, like you're up halfway and you're over halfway. And then by the time you get to pi over 4, you get to root 2 over 2, which is like 0.57, if I remember right. What is root 2 over 2? Come on. Root 2 over 2, it's okay, it's actually about 0.7. So anyway, so there's root 2 over 2, which is like 0.7-ish. You've got root 3 over 2, which is I think 0.83, I want to say. Or 0.87. So you're working your way up here. And then by the time you get to pi over 2, it's at 1. And then it turns around and starts going back down. You see all these values again. And by the time you get to pi radians, it gets you at 0. If you were to continue this, you then have basically the bottom half of the unit circle, and you're going to be moving into negative territory, which is why you're getting negative values for sine. And so if you were to plot it by hand, you would get a curve that looks something like this. And this kind of graph is called a sinusoid. I think I spelled that correctly. Let me check that too. Sinusoid. Yeah, it's a sinusoid. And so anyway, it's the kind of curve you get from a sine graph. And then when we look at the cosine graph here in a minute, it's going to be a very similar sort of shape. It's just going to be in a slightly different position. But that's also known as a sinusoid. Graphs of sine and cosine functions together are called sinusoids. So here, this is just sort of showing you the connection here with the unit circle and the values as you plot the sine curve, the sine wave. It's also sometimes called a wave function because it kind of bobs up and down the way waves do. And so here's the pi over 6 value, which is about that high. And as you get higher, you've got the pi over 4 value, the pi over 3. And again, just to remind ourselves, because we talked about this back before break, but the sine is the y value. So it's going to refer to the height of the segment on the unit circle there. And as you curve upwards, it's getting higher and higher. And so the sine curve is working its way up to the high point of 1. And then once it hits the high point, it's going to turn around and start going back down. And that's why it's kind of this wavy pattern. And then the pattern will repeat because you can keep going around and around in the circle. Here's a very similar table for cosine. Cosine actually starts at the top. It starts at 1. It starts going back down to like 0.87, 0.7. That's going down to like 0.5, and it kind of was working its way down until it gets to 0. It then creeps into negative territory until you get to pi, which is where it bottoms out at -1. And that's going to turn around again. And again, this is sort of a wave function. And like I said, even though this is the cosine graph, this is also known as a sinusoid because both sine and cosine have the word sine in them. And so together, these are known as sinusoids. There are different features of sine and cosine graphs that you're going to be expected to know what they are. And then these features can change as we change the formula. And the overarching goal is for you to recognize and understand if I change the equation, what does that translate to in terms of how it changes the graph? And so that's sort of the goal of being able to make that connection. How does changing the formula change the graph? So the first feature of the graph that we'll talk about is known as the period. And this is the length of one cycle. And so there's a couple ways you can think about it. For the sine graph, it's from 0 to 2 pi here, and it's basically one hill together with one valley. So that's one way to think of it. It's one hill and one valley. That's one way you can think of it. Or if you're another way to think of it is you could talk about the distance from one high point to another high point. That's kind of two alternate ways to think about it. So one high point to the next high point. And for standard garden variety, ordinary sine and cosine functions, the basic period, the standard period is 2 pi. For sine and cosine. And so that's no accident because that's the length, that's the turn, one complete turn around the unit circle. That's the connection there. It's one complete turn of the circle. So since 2 pi radians is a complete turn of the circle, that is the period. And then when you finish that turn, you are then going to repeat that in cycle after cycle as you just keep spinning around and around and around on the circle, on the wheel, if you will. So that's what the period is. It's the length of one cycle. So some characteristics of the graphs. They're periodic functions, so they repeat regularly, and they have a cycle, a period of 2 pi where they repeat. The domain of the functions is from negative pi to pi, so they can go as far to the left and right as they want. The range, on the other hand, is from -1 to 1. The thing you will notice about the sine and cosine graphs is that normally it only goes as high as 1 and as low as -1. And that has to do with the radius of the unit circle, which is itself 1. The graph of sine is symmetric about the origin because it's odd, and then cosine is symmetric about the y-axis, which is making it an even function. So in simple terms, just know cosine is even, sine is odd. So the sine function, that basically means it has spin symmetry. So if you hold this position fixed, if you spin this around this way, this half, if you turn it, will line up on top of this half. For the cosine, it has mirror symmetry. So there's a line down the middle, and it's a perfect mirror image of each other. So this is even for cosine. This is odd for sine. This is like spin symmetry versus mirror symmetry. In case you didn't know, there's actually two different kinds of symmetry. You have the symmetry where it's a mirror image of itself, which is, I think, what most people think of. But there's another kind of symmetry where it's spinning symmetry, where if you turn something 180 degrees, it looks exactly the same. Let's see here. So so the general formula that we're going to be looking at, there's, depending on which function you're using as your starting point, you've got some number A that's multiplied in front. You've got a number B that's multiplied inside the trig function itself. You would be subtracting a value C inside the trig function, and then you would be adding a value of D. And what we're going to do is break down and look at what each of those numbers does to a trig function. So the first one that we're going to look at, or that we're going to focus on, is the value of B. And so what B does is it changes the period. The standard period is 2 pi, and you would divide by the value of B. They do have absolute value lines on there because you're basically going to kind of disregard the negative sign. Whether it's negative would do something different, but if you divide by the absolute value of the B, whatever that is, 2 pi divided by that number, that will tell you the new period. So for this function here, we've got this orange one, which is the standard graph. For this, you have sine of 2x. This would mean that B is equal to 2. And this would mean that it has a period of 2 pi over 2, also known as pi. And so what you will notice is that for that graph, from 0 to pi, it finishes one complete cycle, because it did one hill followed by one valley, and it's one complete cycle, one hump and one dip, if you will. And so the period is now pi. It's half as large. This one, meanwhile, this one would have a B of 1/2, and that would give you a period, if you did 2 pi divided by 1/2, that would actually double and give you 4 pi. And that's why when you go to 2 pi, you've only got half of a cycle, because you're only getting the upper part and not the lower part. But that is how the value of B affects the graph. It will alter the period. The standard period is 2 pi. If you divide the value of B, that will tell you the new period. So here they say, determine the period of the function cosine equals x over 3. All right, so let's look at this. This is cosine of x over 3. That would mean that B is 1/3, because you're multiplying by 1/3, which is equivalent to dividing by 3. For the period, you would do 2 pi and divide it by 1/3. Now, dividing a fraction is equivalent to multiplying the reciprocal, so that's going to be 2 pi times 3. And fun fact, 2 pi times 3 is going to give you 6 pi. So the new period for that equation, that function, will be 6 pi. And this is kind of the main emphasis of the kind of stuff I want you to know. We're not going to spend as much time drawing the graphs ourselves by hand. And quite frankly, if you have a graphing calculator, you can just have a calculator draw graphs for you if you really want them. But I just want you to understand the connection between the formula and the different features of the graph. So next, this is going to be the value of A. And so A is the amplitude. So the amplitude, that's going to be the distance from the middle to the top. So with each of these, we've got a bunch of different ones here where they're graphing different amplitudes. So there's this dark blue one, which is the basic one. This is where the amplitude is 1. It goes as high as 1. If you do 2 times sine of x, now it goes as high as 2. 3 times sine of x, it goes as high as 3. 4 times sine of x, it goes as high as 4. So this is just telling you from the middle at 0, how high does it go? Alternatively, it also tells you how low it goes. This goes down. The one with the 4 goes as low as -4. The one with the 3 goes as far as -3. The one with the 2 goes down to -2. The one with the 1 goes down to -1. This is an alternative way to define it. It's basically half the maximum minus the minimum. So if A equaled 4, that would mean that you do 1/2 4 minus -4. Fun fact, 4 minus -4 is the number 8. And even if you do the absolute value of that, it is still 8. And 1/2 times 8 is the number 4. How about that? If you offset the midline, doing that's maybe a little bit more worthwhile, but anyway, a value that you multiply in the front of the function itself at the very beginning, whatever that number you're multiplying is, that's going to tell you how tall the bumps are. And it'll tell you how low the dips go. And it'll be the same amount. So they say, what is the amplitude of the sinusoidal function f of x equals -4 sine x? Is it stretched or compressed vertically? All right, so here the value of A is -4. The amplitude is equal to the absolute value of A. So that just means that the amplitude is going to be the absolute value of -4, meaning the amplitude is 4. And so the amplitude is, let's see. So the amplitude is 4. And so that means it's going to be stretched vertically. I cannot spell. Stretched. Let's try that again. It's stretched vertically. It's going to get bigger. Okay. Incidentally, for anyone who's interested, there is a reason why this is called the amplitude, by the way. Sound waves can be modeled using sinusoidal functions. That's part of why this is a thing and why it's useful to some people. And if you increase the amplitude, what that does is it's effectively raising the volume. So a wave, a sound wave that has a higher amplitude ends up being louder. And If you know musicians who would use an amp, for instance, to amplify the sound, what the amp does is it increases the amplitude of the sound waves to make them larger so that you can hear them or have them burst your eardrums, depending on just how loud you go. But that is what the amplitude means in kind of practical purposes. The period, for what it's worth, that would actually be like the pitch. If there are any musically inclined folks listening, the difference between, say, a note like an A versus a note like a C or something, the difference in the sound that we perceive, the pitch, if you will, how high or low the tone sounds, that comes from the period. And really high notes have a very, very short period, and really, really low notes have a much wider period. And so that's what the period is. It has to do with the pitch of the tone that you're hearing. So that's why those are a thing, and why anyone would care about them. There's other things they're used for too, but I'm not really a science person, so that's all I can really tell you as far as that goes. But maybe you found that interesting. So anyway, that's the amplitude. Let's see. What is the amplitude of that? And then is it stretched or compressed vertically? Okay, so we got 1/2 sine of x. So fun fact, A is just going to be 1/2. So that's the amplitude is a half. There you go. That's the amplitude. Well, guess what? Since that's a small number, because it's a half, that's going to be compressed vertically, because compared to the basic function, where it's going to 1, here it's only going to a half. So it's going half as high. It's not going as high, so it's lower. It's compressed. The graph is smushed. So there you go. It's an amplitude of a half, and it's compressed vertically. What else do we have? All right, so then this is going to be, we're going to be talking about the phase shift. And what you would want to do is factor out B to separate the period and phase shift. So here they're telling you, so basically the phase shift is going to come from the value of C over B, because you would have to factor this out. And so a negative C over B is going to be, if it's, let's see here. So a minus is going to shift you right, and a plus is going to shift you left, which is kind of the opposite of what you would expect. And if I remember right, I think we've discussed this kind of phenomenon before with other kinds of graphs, but just know that if it's a negative sign inside the parentheses, it's going to shift the graph over. And so here you can see the dark blue one is the basic graph, the parent function. Here's a minus pi over 4, and so it's shifting the graph over by pi over 4, which is right there. And so it's scooting the whole graph over by that much, and it's moved by pi over 4. And then the other one, it's shifted over all the way by pi. So that one, maybe we'll do it in pink. So that one's being shifted all the way over by pi. And so the center value is now scooted over that far. But that is the phase shift. And so you're basically moving the graph, you're sliding it side to side, either to the left or to the right. Okay. The next thing that we have is the midline, which is going to be the value of D. So the midline is pretty straightforward. Whatever the value of D is, that is the midline. So what you will notice is that here it's a +2. So then 2 is the middle of the graph. And then from the midline, you would either go like up 1 or down 1. If you had an amplitude of say 3, you'd go up 3 or down 3 from the midline. And so that will then slide the graph up and down, as opposed to the phase shift where you slide the graph left or right. So here they say identifying the phase shift of a function. Determine the direction and magnitude. Magnitude is basically fancy speak for size, how much basically. So here's this, they say determine the direction and magnitude of the phase shift. So since it's a plus sign, that actually means we're going to go to the left, and we're going to go left by pi/6. And notice there is no b value, which is nice because we don't have to worry about dividing by the b value. We can just, what you see is what you get. It's a pi/6, boom, your phase shift, you're going to go left by pi/6. I say determine the direction and magnitude of the phase shift for this one. So again, notice there is no b value, which makes our lives easier. You will see here, this is minus pi/2. Since it's minus, you would do the opposite of that, which means you would go to the right, which is where the positive numbers are, as opposed to the left where the negative ones are. We're going to go right. How far to the right are we going? Pi/2. That's how far we go. So we're going to go right by pi/2. What else do we have? Determine the direction and magnitude of the vertical shift for this one. So the vertical shift here, you have -3. So the term I'm going to be using a lot is more the midline, but they mean the same thing. So you have the midline at y equals -3. If you wanted to, you could say the vertical shift is down 3. That would be another way of saying it. The nice thing about the vertical shift, what you see is what you get. So negative is down, positive is up. It's the vertical shift is a lot more straightforward. Again, the test question, excuse me. The test questions are more going to focus on asking you to identify the midline. But that's the connection between the vertical shift and the midline. So the exam questions that you'll see, they'll give you a formula, and it'll say like, what is the midline of this formula? And that's all that I'm going to be going for. Determine the direction and magnitude of the vertical shift for this. So again, this is the vertical shift of this function. There's the +2 right there. So the midline will be y equals 2. That's kind of the way the exam questions will be phrased. You could say the vertical shift, since it's positive, that means up. So the vertical shift is up 2. So 2 slightly different ways of saying it. Again, for me, I'm more interested in identifying where the midline is. Let's see here. All right. Let's see. Determine. All right. Here we got the whole shebang. So they say determine the midline, amplitude, period, and phase shift of that function. All right. So We've got that number, we've got that number, and we've got that number. So A in this problem is going to be 3. B is going to be 2. C is going to equal 0 because you will notice that there is no value of C. There's nothing added or subtracted inside the trig function. And the value of D, meanwhile, is positive 1. So the, let's see, the midline is the value of D. So that's going to be Y equals 1. The amplitude comes from A. The amplitude is going to be 3. For the period, this one requires a little bit of work, but not really a whole lot. The standard period is 2 pi. You need to divide that by 2. And if you do, you end up with pi. So the period is pi. And then there is no phase shift because there is no value for C. So there is no phase shift. So there you have it. Those are all the different characteristics of what's happening with that graph. And again, if you break out a graphing calculator, you could see those things in action. And though that's the midline, the amplitude, and the period. And there is no phase shift for that one. Determine the midline, amplitude, period, and phase shift of this one. All right, so let's start with the easy stuff. A is equal to 1/2. You can find that pretty easily. And notice that D equals 0 because there is no value added on the end. So the amplitude is going to be 1/2. And the midline is the standard midline, which is Y equals 0. That's the easy stuff. Meanwhile, we need to figure out what's going on with the phase shift and the period. So this one's a little more challenging than the other ones. So we've got x over 3 minus pi over 3. The b value, to get x over 3, that means the value of b would be 1/3. And what we need to do is we need to factor out b. And the reason for doing that is we want to separate the phase shift from the period so that we can look at them individually. Because the way the formula is written now, they're kind of jumbled together and we can't really, if you say the phase shift is left by pi or right by pi over 3, you're going to get it wrong, basically. So let's factor out this value for b. So that's going to be 1/3, and that would be x. And if you divide this by 1/3, that's going to just be x minus pi. So now what's in the cosine function is this. I think my voice is giving out on me here, but so what's happening here, the value of b is 1/3, and then the value of c is going to equal pi. So the phase shift, since there's a minus sign there, you're going to go right by pi. That is the phase shift. The period, that's going to be 2 pi divided by the absolute value of b. So if you do 2 pi divided by 1/3, that is equivalent to 2 pi times the reciprocal, 3/1, which will be 6 pi. So the period then is 6 pi. Okay. So that is the end of that section. So we'll ahead and stop the recording here.